Most LINQ operators come with overloads that help resolve some corner cases without needing to chain more calls afterward. Are you using the extended LINQ operators? I will show you 3 of them in this video, all 3 serving a similar purpose. Those will be the specific variants of SelectMany, zip, and GroupBy operators. This list contains the domain objects loaded from the database. I will query that list using a LINQ. Beyond this line, the list contains the objects, and we can start using it. Let me show you what the models are. This loop will list the books. Each book comes with 1 or more authors. These helper methods will help you see the structure of this object model. The book itself contains a title, which is an object, not just a string. There is a sequence of authors, each containing an object representing their name. That name object in turn contains a couple of components, such as first and last names. That is the object model we will be querying. It is a very detailed domain model. There is a lot of work awaiting LINQ in this demo. By the way, you don't have to do things this way. Transform the books using LINQ and the toLabel strategy. Then collect them into a list and subject each item to the WriteLine static method. Both approaches will produce the same output. You can see all the books queried from the database. We shall transform these objects in the rest of this demo using special purpose overloads of SelectMany, zip, and in the most advanced demonstration, GroupBy operator. Strap up your seatbelt. The first demonstration will show one interesting ability of the SelectMany operator. We shall start with the books and then extract all their authors. The SelectMany operator flattens a sequence of sequences, producing just a sequence of author objects contained in all book objects. Please note that the same author object might be part of several books. That author object would appear that many times in the output. The SelectMany operator does not remove duplicates. We would convert each into a printable label, take distinct printouts only, and send them to the console. This completes the default use case for SelectMany. But what if the request is also to include the book along with each author's appearance? That will require some planning, so I better start the expression from scratch. First of all, we need the book from which we took each author. The result of this query is a sequence of book-author pairs. Only then should we transform each pair into a string containing both the author's name and the book's title. The rest is straightforward. This completes a traditional method of combining contained objects with objects that contain them in a flattened-out sequence. But the SelectMany operator can help us remove the additional select operator. It also accepts the second lambda, which receives both the main object and the contained object. I used to extract that pair manually. I can transform the pair into the string without an intermediate sequence and the additional call to select. The resulting printout should look the same. This is the SelectMany overload I wanted to draw your attention to. It cuts processing down by 1 step. I will run the application now. All the authors are there. Each line also reports the book's title. You see the effects of SelectMany here. A book with multiple authors would produce several consecutive lines, 1 line per author. We shall now move to the next similar operation, this time supported by the zip operator. Zip operates on 2 or even 3 sequences by combining 1 item from each. This is the requirement. This property returns the first 10 Thursdays of the year. The plan is to organize a single book promotion on each of those days. That is the perfect job for a zip. Let me show you. I am starting a new expression. You would begin with 1 sequence and then zip it with another. The result is a sequence of pairs, where the first component is taken from the first sequence and the second component from the second one. Then transform each such pair into an object of your liking using the select operator. I am formatting the string containing both the promotion date and the book. Zip produces an IEnumerable of pairs of date-only and book objects by taking items from 2 sequences in lockstep. The output sequence ends when at least one of the 2 input sequences is exhausted. You can do whatever you like with the resulting sequence. I'm just about to print it. That is where the overload comes to the picture. It adds a lambda receiving the two items in each iteration. At the minimum, you would give names to the tuple components. Even that can be something, sometimes. This lambda can help you entirely avoid the subsequent select. Instead of paying the cost of creating the tuple only to map it to another object later, you can do the mapping right inside the zip operator. This expression avoids the construction of one additional sequence. Let me run it. You can see the 10 Thursdays in 2025 with one book promoted on each individual date, all thanks to the zip operator. That brings us to the last and most complex demonstration in this video. The request is to display all authors along with how many books each of them has. That is an excellent task for GroupBy. Please note that you can download the entire source code for this video from my Patreon page. Remember that every registered patron is helping hundreds of other fellow programmers watch all the videos on my channel for free, so please join me on Patreon. Now implement the requirement. I will start with all the books and then flatten out the sequence of their authors. Each author will appear in the sequence as many times as the number of books they wrote. Therefore, if I just grouped the authors by identity, each group would represent one author and the group size would tell us how many books there are. We shall then map each group using the select operator. That is where you need to understand how the GroupBy operator works. Each group has the key, the author's identity, which we won't display. The identity was only helpful for grouping all the appearances of one author. However, the grouping is also the sequence of all objects in it. It is the IEnumerable of author objects. Therefore, we can pick the first item in the group as the author object, and the group count as the number of appearances of that author. That count is also the number of books authored by that person. Turning these data into nicely formatted strings is easy. The key to understanding this expression is seeing what the GroupBy operator returns and how the subsequent select operator transforms that into a tuple with two integers. And what if I told you that there is the GroupBy overload, which does all this? Before I show you that overload, please note that even this expanded form has its application. For example, it lets us isolate the authors with more than one book. But what if that is not a request? What if plain grouping is all we were asked for? That is where that overload comes to the picture to replace this entire chain of transforms. It will be the GroupBy again. Only this time I will group by the author itself. Please note that the author class does not implement the I-equatable interface. I will need to supply the equality comparer object, which will ensure that authors are compared by their identity. You don't have to worry about that yet. Right now I want to show you that GroupBy can also accept an additional lambda, which maps the key object, the author, plus all objects grouped under that key. This overload simplifies the task by providing the entire grouping right inside the GroupBy operator. You can map this group into whatever object you like. The GroupBy operator will return the sequence of objects you create here. I have formatted the string for printing again. The overall result will be a sequence of strings. The last touch is to add that equality comparer for authors, which uses identity as the equality key. You must prepare an object of this kind whenever you use a class as a key that is not equatable, for example in hash sets or dictionaries. Let me run the application. You can see that Robert Martin and Martin Fowler have written 2 books. That is what I have in the database at least. That completes the story of 3 special form operators you might want to use. They will help you avoid unnecessary chaining of multiple operators in situations where one LINQ operator can complete the entire transform you planned.